Awesome. So I'm David. Thank you, Sergey, for introducing me. My current project that I'm working on is, as he said, is LookZook.com. I'm also a contributor to the Chromium project, particularly with Blink, which is the rendering engine behind Chromium. And so because of all the work that I've done with the Chromium team and with LookZook and my experience in the web dev community, I've seen this common this thing that's been developing over the especially last couple of years, in terms of Amazon seems to be one of the best and most performant websites out there. And it seems to be what most of us, especially those of us in the e-commerce space, right? Because Amazon is always coming out to eat our lunch, right? And so we always find ourselves competing against Amazon. And so I'm going to be going over kind of some of the things that I found that Amazon's doing that a lot of us aren't. Maybe some little things that actually save you a lot of time just by, just little tidbits that I found here and there. But before we get into it, I just want to say that sometimes I really feel like in the WebPerf community, we are pushing we are setting the bar really high, which is good, but sometimes we are way too hard on ourselves on some of the performance. All right, we're doing a fantastic job. WebPerf is just way harder than it's ever been before, right? Because the fact of the matter is, speaking of the slides to work, that'd be great, is that this is how to be a web dev in 2017. Make sure your website is usable in an office, subway, or free airport Wi-Fi across countries where it says you have 3G and full bars, but you barely have 2G and 1 bar. The page must be usable on Gecko, Trident, Edge HTML, WebKit, and Blink. And oh, don't forget the over 116 different viewport sizes across Android and iOS. Build your pages with Gulp, Grunt, Broccoli, maybe Webpack, NPM scripts, or even Makefiles using a new task runner. Every project is okay, if not actually encouraged. Images must be available in several different responsive resolutions and 8-bit encoded to minimize size. CSS should be inline, modularized, or concatenated depending on its use. All JavaScript should be fetched asynchronously, but sometimes synchronously to ensure execution order. Minify, gzip, and properly cache all JavaScript, CSS, and HTML to be served up by CDN with a renderable payload within 14 kilobytes. That's web dev today. This is what web dev used to be. Make a GeoCities account. You just throw it up there. We'd send credit cards through cookies. Security wasn't a thing that we'd really think too much about. And if you were really, really pushing the bleeding edge, you use Macromedia. Yes, Macromedia, not Adobe. Macromedia Dreamweaver to maybe make a little makeshift blog, and you'd go in once every couple of weeks to push little updates to your CSS, right? It's way more complicated nowadays. Which is why I really feel like all of us, when it comes to web performance, we feel like we're always kind of like in a labyrinth, right? It's kind of hard to see the end. There's so many different pitfalls we can fall into if we're not careful. You have to kind of look behind you and forward at the same time. It's really confusing. And so what I want to do today is really use Amazon, someone who has, I think, really seeing the end of the tunnel. They're outside of this labyrinth, right? They've successfully traversed it, right? They've gone around all these traps and pitfalls. And I want to use them as kind of like this guiding torch, like a tour guide, to really help us, guide us through some of these common pitfalls all of us might actually be falling into, all right? But first things first, before we go and try to tackle and see some of the different things that Amazon is doing, I think it's really important to know the beast. Right, we have to know, what does a regular website look like, what does Amazon look like, so we can kind of see maybe some of the disparity. So we're going to run through what we call a browser playback, right? We're going to watch basically Amazon versus Walmart run, and we're going to just kind of see the difference between both of them. All right, so we're going to hit play, and we're going to go in. So we see in a second or under, Amazon's basically done with their page. I mean, it's amazing. And Walmart literally has nothing, right? And we're going to keep on going here. And it looks like Walmart's doing pretty good, but if you check it out, they don't even have their buy button yet. That's a pretty big problem. And Amazon has literally everything on their page done. So for all intents and purposes, Amazon's, we're done. We're done here. So let's just look at what Walmart's doing. It looks like they're done, but they forgot their buy button. So let's just wait here. Still not there. We're getting there, I promise. All right. We have a buy button. We can do what we came to the page to do. All right, that's great. All right. So clearly, Amazon is doing something correct here, right? So how about as a first step to kind of seeing how Amazon traversed these labyrinths, let's just take a look at their source code, right? It must be absolutely beautiful, pristine, follow all these web standards perfectly, right? Wrong. It is a insufferable mess. It is atrocious to be nice. There are scripts literally in the header, in the footer. There's scripts inlined. There's style sheets actually inside of the body, which is something that people tell you never to do. It should always be in the header. It's literally a mess. This is nothing like anyone would ever tell you web performance is supposed to look like. I mean, but clearly they're doing something right here. I mean, because their web page loads faster than anything that I've created many times, and clearly they're being Walmart by 5 times the speed. All right, so I think what might be a little easier than going line by line in the source code is let's just kind of go back and go through how a web browser actually starts to render your page from the request to the pixels being on your page. And along the way, as we go kind of more in depth in various parts of these, we'll take a little break and we'll kind of go back and forth between stuff that Amazon is doing now with our newfound knowledge in these things. So, all right. So first thing is DNS. I'm sure everyone here knows what DNS is, but if there's anyone who doesn't, basically the way the internet works is that you give the web browser a domain. Right? You want a domain address like, say, LookZook.com, okay? The point of the fact, though, is that the internet actually operates on IPs, right? It needs an IP address to go to, all right? So what happens is DNS is you can think of it kind of like a GPS system, right? When you are trying to navigate to something with GPS, you enter a location, like an address, all right? And then it, through a series of mechanisms, translates that address into an actual longitude and latitude coordinate, all right, similar to this. So to keep it kind of brief, what happens is your computer, if it doesn't already have the IP address stored, it's going to make a request out to what's called the resolver, which is, I'm sure some of us here have heard of 8.8.8.8, Google's public DNS, I use it all the time. I'm sure many of you guys do as well. The resolver's main purpose in this is to basically act as a mediator between all the rest of the steps, to make it really easy for your computer to basically just make one request and get one request back, right? So basically you ask the resolver, hey, do you have Twitter.com, all right? So the resolver is then going to say, well, I don't have Twitter.com, but I know that the .com name server, which is all these name servers are basically, you can think of them as almost like hash tables that are stored in different servers across the world. And what it's going to do is the name server says, oh, well, I don't actually know where Twitter.com is, but I know the guy who does. And so it's going to send that information back to the resolver. And the resolver is going to go back and say, hey, I was told that you have the name. You have the correct IP address for this, do you? It does indeed. And now you have the correct IP address for this, and you can get going. There's only one problem in this, is that this whole chain of events can take up to 100 milliseconds. So as soon as you have to make any DNS request, you're already losing. And if your web page has any external resources, if it has images hosted on different subdomains, if you're reaching out to, say, CDN.js to get another script, chances are you're probably going to have to make a DNS request. And even worse is that if you're on mobile, this 100 milliseconds can easily turn into 250 milliseconds. And that's for every single request. And the main problem here is that you haven't even sent a request out to the server yet. It can't do any work whatsoever, all right? So how do you fix this? Well, the first thing you do to fix this is you follow basically what Amazon is doing right here. This is straight from their source code. You use what is called the DNS prefetch. What you do is you put this is a cool little link tag that you can put inside the header of your HTML. And you basically tell it, hey, here are all the domains that I think I'm going to be using either now, in the future, later in the page. And it allows the browser to basically expedite all of those DNS requests. And so basically, instead of you waiting for the browser to discover, hey, I kind of need to go to m.media-amazon.com. You can tell it up front, right now, I'm going to need this in the next page. So you can speed up the next page's response, right? And so you can save yourself hundreds of milliseconds, sometimes seconds, especially on mobile devices, right? So that's the first thing that I see a lot of people don't do that Amazon is doing. They have these literally everywhere cluttered across their pages. All right, so that's DNS, right? We got the address, but now we move to the big meat and potatoes of how we actually get the goods from the web page, right? And that's TCP, the famous mailman of the internet. And basically TCP, to keep it really simple here so we don't go into a whole separate discussion of this, is TCP basically works just like a mailman does, just like the USPS does here, right? You give it a package you want delivered, you give it the IP address, or for the USPS, you give it the address you want to send it to, and it's going to deliver it there, and it's going to pass it along to a bunch of other different depots along the way, and eventually it magically appears at your doorstep or your friend's doorstep, right? It's fantastic. There's only one problem with TCP, is that it wants to deliver the resources that you've requested or that you want to send out as fast as possible. Right? We're all performance guys here. We love things to be delivered as fast as humanly possible. But the problem with this is that it has no idea what in the world the bandwidth that you can actually hold or process is. It has no idea. Because even if you had a 100 megabit connection, you might be watching, say, Netflix. Or maybe one of the depots right above you is, maybe the Ethernet cord is pulled out for half a second. I mean, it has no idea what's going on. And the main problem, and why this is such a problem, is that if DNS sends way too much, not DNS, if TCP sends way too much information, it basically is just like this, this cup of water, right? All the data it sends you starts to overflow. And that's data that you don't get, that it thinks you have. And so what ends up happening is that you have to go back and say, hey, I didn't get it. Can you send it again? And you go back and forth and back and forth and back and forth, and it's absolutely terrifying, right? So no one wants that. So the brilliant guys who made TCP came up with this brilliant thing called TCP Slow Start. And the way that Slow Start works is it says, all right, we're going to start with a payload, and here, if you can't see this point down here, this is 3. All right, this is 3 packets, which is about 4 kilobytes in size. So the first request that TCP is going to send to you is going to be basically 4 kilobytes in size. All right, and if it sees that you were successful in receiving those 4 kilobytes, well, maybe you can receive 8. And if you received 8, maybe 16, 17, and after that 34, and then after that 68, and it keeps on going up and up and up and up and up. And if you miss one, it'll kind of shove you down to the next level, go up and down, and that's how it magically finds out what your available bandwidth is. It's a very elegant and simple solution, and it's worked for eons. There's just one problem with it, is that according to the HTTP archive, the average HTML page that you request online is 50 kilobytes or more. Which means that if you are making a cold connection out to the web page where the HTML is hosted, it's going to take at least 4 round trips to get the information you want. And here's why it's a problem, is that if I'm in London in a coffee shop and your server is hosted here in New York, if we're going the absolute speed of light, right, completely ignoring that different handoffs TCP has to do, the fact that Ethernet actually is not the speed of light, we're dealing with 100 milliseconds every single round trip. So that means back here, these 4 round trips, that's at least 400 milliseconds. Or, if you're on mobile, over 250. Which means that, well, that initial request of 500 kilobytes, that can eat up 1 to 2 seconds. And that's before the browser can show anything. It hasn't requested any other CSS. It hasn't done any JavaScript. It basically hasn't gotten much cold turkey yet. All right? But there is some good news. Is that the guys at Google said, hey, we need people to get faster load times. This is a big pain in the butt. And so they did a great research study, and they found out that TCP, when they made these initial limits to what the starting packet size should be, that was way back when we were on dial-up, right? We're on broadband now, we don't need that. And they found out that we can actually increase that initial size to around 14 kilobytes. If any of you have ever heard the, like I said in the preview how to be a web developer in 2017, that's where the 14 kilobytes comes from. That's the maximum amount of information you can rely on TCP giving your browser, right? That's why it's important to make sure that that first 14 kilobytes you get from the browser is actually renderable, right? That's where that comes from. And as you can see here, we're down to 3 requests. So we've saved potentially on mobile, like between half a second to a second sometimes. It can even be more. And there is one really good news, though, is that I think basically everyone here, as long as you are not on Ubuntu 12.10 and you've upgraded in the last 3-4 years, you are already using this. Your web page has already been sped up, so if you're on any legacy systems, make sure you update the kernel manually, or you should just update your operating system entirely. All right. So that's great. That's a nice, easy win that all of us can kind of feel happy about. Hey, we're doing this. Amazon is doing this. You know, we're on the bandwagon. This is great. Things are looking good. Only one problem. This is a common problem I see all over the place. Let's say you have a basic WordPress blog, all right, or a WordPress blog you turned into an e-commerce web page, all right. The problem a lot of people run into is that TCP would love to start sending out the content of your HTML page as fast as possible. The only problem with a lot of WordPress sites and a lot of sites in general is that can take your server up to 200 milliseconds or more before it actually spits out a response for TCP to do absolutely anything with. Right? It's sitting there waiting like, hey, I want this information, let me send it. But you're literally pushing it away, you're not letting it do anything. So what you can do, though, is you can be like Amazon, and you can use what's called transfer encoding chunked. It is an HTTP header you send out in your initial request and response from your server. And basically what it says is, hey, I want to stream you the HTML as I get it. And what this does is if you, say, had a WordPress blog page that first sends out a database query to generate maybe the first post and the header, and then sends another database call to get the sidebar and maybe the next couple posts. Because a lot of WordPress sites don't just do one database call, there's up to like 10 or 20 per page load. Instead of just sending out the whole, the whole kit and caboodle right at the end, you can very easily go into PHP or Ruby, whatever you're using to host your blogs or your sites, and you can just what's called flush this out to TCP as fast as possible. And so you basically end up streaming this information out. And so now you get 3 benefits. One is that you are basically allowing TCP to increase its what's called the window size, like we saw back here, right? You're allowing it time to increase its window size, right? Because as you're saying information, it's finding out what the potential of the network is, all right? Which beforehand, it had no idea until it sent it to you, right? Because it's not manually going to go try to figure that out, right? That could be a complete waste of time. So what it does is first, now when the request is actually done and the browser comes and say, hey, I'd like that image on your site, can I please have it? Chances are TCP's window size is already big enough to send you the entire image in one trip instead of 3. Huge savings on time and bandwidth. It's absolutely fantastic.
How does the chunk interact with this size you're allowed to send? I didn't quite get that.
So the way that TCP works, right, it splits everything up into different packets. Okay, and so what these the segments here are basically the maximum size of the basically conglomeration of all the packets that you're going to send out. And so if you think of TCP kind of like a mailbox, whenever I'm sending out, flushing data out to TCP, I'm basically saying, hey, here's the data. I'm going to populate basically this first segment that I want you to send out, and I'm going to push it out to the browser immediately while I'm actually still generating a response.
Okay.
Does it clear anything up, or?
Yeah, so you can flush data at kind of the same rate that you're allowed to send it through that size anyway.
Right, exactly.
Rather than waiting until you have everything, which is too big to send.
Right, yeah, you're allowing the browser and TCP and your server to do work in parallel, is essentially what it's doing. Instead of having a bunch of blocking requests and responses going on, you're streamlining everything.
David, am I getting it right that there are actually 2 benefits? One is that some information getting delivered earlier, but also that it triggers the opening of its...
Right. Exactly.
So next information is delivered faster as well.
Right. Yeah, yeah. Exactly.
But to send anything, you have to already have your headers, right? You have to always send headers. But you can't just...
Right. So what would happen is that when you make a request out to the server, the browser is literally sitting there waiting for anything to be returned, right? Because TCP is basically, it is just a stream of information. And so the first thing, if you've ever looked at an HTTP response back to you, you'll see that it lists all the headers first and then it spits out the content. And so when the browser goes through and says, oh, HTTP chunked, all right, great, now I'm going to switch modes over here into a chunk mode where I'm going to basically parse this in chunks and I'm going to look at it. So yes, the headers do have to get sent out first, but you can do that in the first chunk and the browser picks it up automatically. It's smart about that. All right, so that's kind of the network in a gist. There's a lot of other stuff deeper down, but for now, the TLDR here is, one, you want to use DNS prefetching for all of your resources, future page resources that might not be on this page, but might be on one that you'll navigate to later. So don't just think about the current page, think about what the user's journey throughout your pages are going to be and get the DNS prefetching done now. Two is make sure you're using what's called IW10. This is IW10, that's just kind of what they call it, which all of us should have. Basically, just update your servers to use the latest operating system, and it's an easy win. And secondly, you should be using transfer encoding chunked. All right? So we got the goods. It's now time to actually look at how the browser renders your page. All right, this is the cool stuff. So to make my life and your life a little bit easier, we're going to pretend that Amazon and the little example HTML that I'm going to show you does not have any JavaScript, because if the browser has rules for when it can render, like I before E except after C, JavaScript is the humongous list of exceptions to that rule. All right. So we're going to first look at basically the parser, right? This is the part of the browser that takes all of the text on your page, turns it into actually meaningful data and tokens, all right? So what's important to know about the parser is that it doesn't go through randomly through the information that you have received, right? It goes top to bottom just like this, right? It receives this part first, then this part, and it keeps on going down in a procedural fashion, doesn't skip around until it reaches the bottom, right? It goes top to bottom, all right? So while it's going top to bottom, three things are happening at once. One is that it's creating what all of us who have ever been in JavaScript before know as the DOM, right? It's the document object model, right? It's what enables us in JavaScript to actually search for different elements, right? So what happens is if it finds, the body element, it's going to make a body kind of node, and then it's going to have all this children underneath it. If it finds any text, it's going to turn those into textual nodes, and it basically makes a tree diagram of your entire page. What happens after that is, or rather during that, my apologies, is any CSS that the browser encounters during the parser stage is it creates a separate tree diagram called the CSS-OM. All right, and it is basically, it's very similar to the DOM, but that it holds all the style information, the specificity rules, everything relating to what do I actually need on these pieces of content, like how am I going to actually style them, all right? And then when any of these are updated, the browser is constantly going, back and forth, marrying these two DOMs basically together and creating what is called the render tree, which is what the browser is actually going to render. It is the conglomeration of both of these. So as you can see here, the render tree for this would be basically exactly what's in the CSS on, but you would not have the main tag here, because I've told the render tree, hey, I don't want it to even be rendered, right? That's what display none does. So there's something really interesting that goes on here, though, is that we said that this stuff is constantly getting married together, and the browser is constantly updating this render tree. So what happens if I have multiple style sheets on my page? One has successfully loaded, the browser's parsed it, but there's another one on the way. What does the browser do? Does it show information? Does it wait? What happens? No, it waits. CSS and all the CSS you request is completely render blocking, right? If you have any CSS coming in, it is blocking your browser from actually rendering anything at all on the page. And that might sound absolutely crazy. What in the world are these guys working on the browser doing? That sounds like a terrible decision. But the thing is, if you think about it, the alternative kind of makes sense, because if you have multiple style sheets loading in and out, the page could literally jump up and down and left and right and flash back and forth. You might actually need a epilepsy kind of caution tag on every single website you go on, because it would be absolutely crazy. All right, so they were very smart in making this decision to actually save our web viewing experience. And the other nice thing is that rendering on a browser is incredibly complex, and it takes a lot of CPU and battery life if you were to continuously run that. I mean, unless you're in Chicago and it's incredibly cold out and you want a $1,500 lap warmer, then you probably don't want to be rendering the page every single time you load a different style sheet. So, but here's the thing, is that we're all smart here, right? We're all very ingenious people. We can come up with creative solutions. So what if I actually design my CSS to not make the page jump up and down, but I modularize my CSS, right? So I can actually load this one, and the next one coming in can load completely different content. It will not touch it. It won't make stuff jump all around. I'm okay with that. Can we make CSS async? And the answer is yes, you can. And that's exactly what Amazon's doing. And this is the second huge part that Amazon is doing that speeds up the viewing experience of their page, is they are loading all, if not almost all, of their CSS asynchronously. And the great part is that you can do it. It's incredibly simple to do it yourself. There's a great library called LoadCSS you can find on GitHub.com. It's literally github.com/ it's easiest you go to Google LoadCSS, right? It's from the Filman group. And what it does is it plays a couple really cool little browser hacks to make it work. So I don't know if you've ever looked into what you can actually stuff inside of a link style sheet in the header, right? There's actually a cool little section where you can tell it what kind of media types you want the browser to use this type of style sheet for. And if that sounds crazy, we've all actually used it before, because that's what print CSS is. It's literally CSS that the browser is going to fetch and use depending on if it meets the specifications you set. And the reason why, the thing that's really cool about this and enables this to work, is that the browser wants to make your viewing experience the best possible, right? So if I have a bunch of different media style sheets, and they're all for, hey, I want this style sheet to be used for if my phone is of width of 320 pixels, and this one should be if it's 600 pixels, right? So you'd think that would be great, and if I'm on an iPhone, the Chrome should only load that first one, right, 320 pixels. The only problem is that if I rotate my phone, all of a sudden I need that other one too. And think about what a terrible experience that would be to have to wait for the CSS to load, especially if you're on 3G, that's actually 2G, but on one bar, right? So it actually downloads both of them. So what this does, plays a little cool trick on it, it sets the media type to be something that it could never actually be, but all browsers actually still download it. And since it's inserted via JavaScript, it can detect when the script has been fully loaded. And when it's been loaded, it changes the media type to be something. It actually changes to media equals all, which means that, hey, browser, I actually want to use this. And that means that it loads instantly, it changes it, and no more render block. It's fantastic. You can see this. Amazon has a slightly more, very bloated version of this, and it's cluttered all throughout their source code. If you actually took a look at some of their source code, there's huge blocks of JavaScript literally just loading in CSS files. So you could do it that way. I find that way a little messy, but there is a modular or future way that looks like it should be happening in the next year or so of what we're able to do. And it looks kind of weird here because there are style sheets inside of the body, and I was told to never do that. The thing is thanks to IE, and this is actually a good thing. This is not a bad thing. This is actually thank you to IE, right? I can cross that off of my bucket list that I thanked IE for doing something good, right? IE actually came up with this really great idea because in the spec, the HTML spec, it actually doesn't say what to do if someone puts a style sheet inside of the body, right? They didn't actually think that far most of the time. And so what IE does is if it finds out that, oh, hey, here's the header information, and, you know, maybe above here I've inlined some JavaScript, I've inlined some CSS to, you know, what the header needs to look like. All these style sheets only block the content below it. So if I need the header, I can load the header up, I can load the post up here rather, and it will only block content underneath it, right? So I can load the post first, right? Style sheet and the post renders. And then for the sidebar does wait, the sidebar does wait for the post render, but that's not as important, right? So we can start to actually prioritize how we want the browser to load our page. We can almost start to pick and choose what is most important. I want the buy button here to load first, and then maybe the sidebar with the related icons here, and then I know people want to go to their account, so I'm going to load the header up here, and you can actually start to procedurally decide when you want the browser and where you want the browser to load things. It's fantastic. Currently, Edge and Firefox are the ones who support this, and Chrome is following along. We've currently decided that we are actually going to be copying exactly what Edge is doing. It's been in development. It was, it's got caught in standards a little bit, but it looks like everyone has basically come to the consensus that we are going to follow this. And so within the next, I'd expect 6 months or so, we're going to see this inside of the stable version of Chrome. So that's pretty exciting. So now we've kind of oh, yes?
So what's the current browser with link tag
with this? So what current browsers do is it basically loads it as if it was in the header. So you can literally use this now and nothing will change because the browser will, and it's literally as if it's in the header. It doesn't see any difference. So if you don't want to clutter your page with a little bit of JavaScript and load asynchronously, you want to do it the future way and be really cool, right? You can do this today, no performance hit. Yeah.
So two things. One, when you load CSS in the header, doesn't the browser cache it and would it cache it there? And two, wouldn't this cause duplicate CSS files?
Why are you saying that this would cause duplicate CSS styles?
Well, if you have, things in your comments CSS, if it's like that's specific to that section, that some of those styles might also.
Oh, that you might have duplicate styles and selectors. Right. Okay. So, if I'm understanding correctly, you're saying that by modularizing all of my CSS, the main downside is that I might end up repeating a bunch of code. Right, okay. So yes, that is a real concern that actually does happen, but basically to cut to the point, every single, and basically it comes to a trade-off, right? If you want to be able to control exactly what the browser is doing and when, you can you can use a method like this. You could put all of it inside of one piece of CSS and load it via load CSS, just like Amazon does. Amazon doesn't modularize all our CSS. They're doing basically they might be concerned with what you're talking about here. I, for one, I'd be much more in the realm of saying that in your post CSS and sidebar, maybe you don't actually even need to put every single piece of CSS that actually loads it. Maybe these are all just minimal files. Because thanks to TCP, or thanks to HTTP2, I'm not going to get into that in this talk, but thanks to that, we can actually send a lot of different HTTP requests without incurring too much of a downside to doing that.
What about the browser caching?
What about the browser caching?
So the CSS file in the header gets cached by the browser, right?
Yeah, all CSS requests would, as long as you're setting the cache control headers to be correct, it would cache it, yes.
Oh, so whether or not it's in the header, it doesn't
Yeah, exactly, okay, yeah. I mean, it doesn't matter where it is, it caches it all the same. Yeah. So if you did this and you're on Chrome right now, which doesn't support this, you literally won't see any difference in your page. It doesn't matter. Yeah. All right. So let's bring back JavaScript. All right, because that's a pretty important part of our web pages. So let's revisit the parser here, and let's basically see the huge list of exceptions of how a browser renders a page here. So before, when we were this far already, the browser was basically just downloading the style sheet, right? The only problem is that the parser, as I said, parses top to bottom. And thanks to old DOM 1.0 document.write support that the browsers still need to have, even though none of us should use that, and it's been shunned for years, they still have to support it, and that means that this script right here can literally inject code into the parser and screw everything up. And so what happens is the parser stops. As soon as it sees a script, whether it is inline, if it is external, it stops and it waits, which means that all the content down below is now not being parsed, it's not being put in the DOM, the render tree is not being built. You're basically between a rock and a hard place when you do this. The one little upside to this is that browsers saw this as a problem, and so to kind of basically patch fix this, they spin off a separate instance of a parser to basically keep on going down and see if they can find resources that need to be downloaded, so that your downloads don't get limited. But the DOM and the render tree and CSS are all still waiting at this point. So here's the next exception that JavaScript does, which is lovely. So you'd imagine that this is JavaScript here. Let's imagine this is cached, right? It should execute immediately, right? Wrong. CSS actually blocks JavaScript execution. Kind of sounds funny, but it makes a lot of sense, because if it didn't, you see, scripts commonly request the DOM for information of, hey, what's the size of this div, or what color is this font size? And you might be making terrible decisions if it doesn't give you the correct up-to-date information. And so there's actually a humongous paragraph inside the spec saying, hey, really, it's up to you, browser, to decide if you're going to block or not, but we'd highly recommend you stop here, because who knows what's going to happen to these scripts. You can't rely on anything, right? Imagine doing test-driven development without stopping here, right? You literally would get a different result every single time you go on a different browser. I mean, you would have no idea what's happening. So, right, if you don't wait, it gives you bad data. So no one wants that. So what are we going to do? We're going to do what we were told to do 5 to 10 years ago, which is to put all scripts to the bottom of the page. And by doing that, that means that by the time the parser reaches the script, there's no more DOM that really needs to be built. Everything is all hunky-dory. We're all totally fine, ready to go. Only problem is that even if we move to the bottom of the page, as soon as the parser sees that, it stops the renderer, because JavaScript does block the render. It's a render blocking and parser blocking. So how do we get around that? Well, if you promise to be really good and not to use these old DOM version 1 APIs and libraries like document.write, there are these beautiful things that, again, thank you, IE. No, I'm not actually being sarcastic. IE actually, back in Internet Explorer 4, created this great little tag you can attach to your scripts called defer. And what defer does, and there's a great diagram down here, whenever your script, and the downloads are blue, red is execution, all right, just so people know the legend here. When it finds a script that needs to be downloaded, it downloads it, it doesn't stop the parser, and then as soon as the page has finished being parsed, right, DOM content loaded has been sent off, that's the event that it's waiting for, it runs all the JavaScript that has been deferred in order that it's been queued up. Right, so that's kind of a cool little thing. You can actually do async JavaScript while actually keeping execution order. You don't have to do all these funny little hacks around it, right? But there are some cases where we want to execute our scripts right away, like say analytics, or maybe we're loading the React library, and even though we did all this server-side JavaScript and we inserted in our pages to render really fast, we want to let the user actually use our page faster. And so that's where defer kind of fails, because it waits for the page to finish loading. And so in the last year or so, we've gained a lot of support for the async tag here. And it does the exact same thing that defer does. It downloads the content, but as soon as any script, it ignores order. So if you have script 1, 2, and 3, and 3 finishes first, it's going to execute it immediately. And so that's how you do async JavaScript. This is one of the other things that, unfortunately, a lot of sites that I still work with and look on are not doing and taking advantage of. And if you look up, and if you go into the Chrome DevTools, you just press F12 and you look at Amazon's page, it's just cluttered with async script, async script, async script. I mean, they're literally hardly ever using anything other than an async script. Yep.
sounds like defer would be preferable over async because you can ensure the execution order.
Yeah.
So, but are you saying that async is useful?
They're kind of two different use cases. If you don't mind your script waiting for the browser to finish parsing all this, remember, because for DOM content loaded to go off, all that CSS has to be downloaded because CSS blocks rendering. So as long as you're okay with your JavaScript waiting for, I mean, it could be 5-10 seconds, you don't know, then yes, that is actually a fantastic solution. But because of that humongous downside, I tend to recommend people only use that for resources that are not important. Yeah.
In a general sense of browser support, Defer is newer, right, than async?
No, Defer has been around since IE4.
Okay, so
Yeah, it's been out there for forever. And async is, and if you go on Can I Use, I'm sure a lot of us here have seen that page before. The browser support for that is, I mean, basically as long as you don't want to support, as long as you're okay with not supporting like IE8 and stuff, you're totally good to go. Yeah. Yeah.
Is there a reason why you would choose to use async over defer? I mean, what I heard was it's okay to use async sometimes, but you like using defer.
I think I got flipped. I prefer using async for everything I possibly can. Because, I'll just repeat this really quick, the main problem with defer, if you look here, is that your scripts don't actually run until the page has been basically completely finished. So if you have a lot of style sheets, right, because remember we touched on that point earlier, that the browser, when it's parsing through your page, it stops rendering your page when these style sheets are loading, right? And let's imagine one takes 2-3 seconds, right? Your script might have finished downloading instantaneously because it's cached. So in some cases, you would love to run it immediately, and that's what you use async for. Does that kind of make sense? Okay, cool.
Does it matter? Sorry, does it depend on basically who wrote the JavaScript and why? Because I can imagine a lot of, as you mentioned, analytics. You act like as long as it fires eventually, I'm fine, right? But
Yeah.
if it's your framework code, you want to run it earlier, right?
Right, exactly. It is completely preference-based and use case-based. Yeah. The important thing to know is that both of them exist, and both of them are incredibly powerful tools that we all should be using. Yeah.
I just want to make sure I understand the bottom of your diagram. The blue line is loading while the page is rendering.
Right.
But that red line on the async, that's what is happening at that point?
So that's the execution.
Okay, so
It's
that's
executing the JavaScript at that point.
okay.
Yeah.
So it's already loaded. It just takes.
Yeah, as soon as anything async script loads, it executes immediately.
The standard way is it's blocking rendering to load JavaScript.
Yeah, it even waits for it to load. Right. Yeah. Yeah.
Okay.
All right. So you'd think that would usually be, all that's involved really in parsing, delivering some of the goods and rendering some of the stuff on the browser. But there is one big thing that I don't want to overlook here, and that's fonts. Everyone loves using custom fonts. We all love customizing our web pages, making them ours. Who wants to use Arial anymore? This isn't back in the IE4 days, right? I want to use Roboto font. I want to use Open Sans, right? It makes your web pages look beautiful. There's only one caveat, and by one I actually mean 4. Is that fonts are actually surprisingly troublesome. There's a lot of people actually who work on the Blank and Chromium project that hate web fonts because of all the problems they cause and all of the issues that people bring up regarding them. Because the thing is basically when you have that render tree done, right? Everyone remember the render tree, right? It's going to send that off to what we'll just call the renderer, right? Which is basically Blink, right? That's the part that I helped the team out on. What happens is Blink is now, or rather the render is now taking all this information, it's running all the different text blocks, it's rendering the divs, it's making your page look beautiful, right? You want people to be able to buy the stuff, and it's helping you do that, right? It has your best interests in mind. The only problem is that it also has the user's best interest in mind as well. And so what happens is the renderer wants to show the user what you want it to show the user, right? It doesn't want to show it something conflicting. And so if it gets to a text block that needed Roboto, and Roboto is not loaded yet, the browser is going to wait up to 3 seconds. This is the same basically across every single browser there is. All right. So that's, I mean, Safari is the same way, IE is the same way, Firefox, Chrome, you name it, they're all basically act the same way. They block rendering that text block for up to 3 seconds. All right. The rest of your page will download, and that's fine. And in fact, I think it might be helpful to kind of, let me just look back here really quick to kind of show you exactly what I'm talking about here. So let's just kind of go back in time here. I think it actually happened. Yeah, I think we might need to go back even further here. Apologize. We're going to go step by step the browser rendering this thing really quick. All right, perfect. This is essentially the problem we're talking about right here. You see how some text is loaded? That's because this text is basically Arial Helvetica, right? The browser already has it. The renderer came across this text node and said, hey, I can render this. Awesome. I rendered the text. Thank you, right? It's done its job. Only problem is that all this text that we know exists down here has custom fonts. And because of these custom fonts, nothing is being shown on the page at all. It's a big problem. And so what happens is that after the browser waits basically 3 seconds, it gives up because, as I said before, it wants the user to have a good experience, right? It's concerned about you, but at the same time, it also wants its users to have a good experience, right? So it throws in a substitution font, right? Which is basically whenever you make your font family Roboto, Helvetica, Arial, Comic Sans, right? It's going to go through that list in order until it finds one that it can use right now, because no one wants to wait 3 seconds to be able to read the article, right? When you see all the content around it, it feels terrible. But there is a good thing, and that's the fact that the renderer is also a benevolent ruler in the fact that as soon as your text loads, and sorry, Walmart's a little bit slow here, so we actually have to go through. Let's just click forward in time here. No, it's still not loaded. There we go. You kind of see there how let's get to the exact point. See how the text switched? Can everyone kind of see that? The reason the text is switching is that custom web font you so desperately wanted to use is now available. It has been downloaded. And now the browser is going to re-render the portions of the page that it needs to show the correct web font. So this is where, I don't know if you guys have heard this before, this is what's basically called the flash of unstyled text, right? The text is not styled the way I want it. Or the flash of invisible text, which Walmart actually has both of these problems. So there are 2 methods to remove this. But there is a little bit of a heartbreaking moment, and that's the fact, if we want to do this the Amazon way, you have to load your page without no custom web fonts. I'm not saying you can't use them. I'm saying that web fonts can't be something we design around. They have to be something we progressively enhance our websites with. All right? I need to design my page to use like Arial and Helvetica. There's actually a lot of great fonts that are in 99% of all users' laptops, desktops, and phones that we can use and actually make our pages look great. I'm sure when you saw Amazon's page here, most of these fonts are just browser fonts, so you can still make your page look beautiful without them. But you want to load your page first without any custom fonts. Second is Amazon does something ridiculously clever, and I love them for this. It's so Amazon to make a hack and make it work, right? Is that Amazon renders the page first without any custom web fonts, right? But it does want to use those web fonts still because, that's kind of its brand. And so what it will do is it has JavaScript request that web font, the WAF2 fonts that you want to use, like Roboto or whatever, right? Or as Amazon's case is its special Amazon font, right? So now it's made this request, and the request comes back. It doesn't do anything with the data it received. It just knows because the browser has cached it on disk now. It is now available and ready to use. And so they do a really cool hack here. It's that in this local storage, and this is the Chrome view of local storage, they set a little key that says what fonts are available as far as it's concerned to your browser, what fonts are actually cached in here. And so what happens is that on future page loads, when Amazon loads the page, it sees, oh, hey, in local storage, it looks like I actually have the Amber font. I'm going to use that initially right away. And so you don't get the flash of unstyled text because the browser has it available already. It's on disk. And you don't get the flash of unstyled text because I mean, for the same exact reason. Now, as much as I like this way, it is a little bit, it's not good enough for me because the thing is that the cache on especially mobile phones is it gets wiped out so fast. If you're on an iPhone, this thing can get wiped as fast as closing the web browser. It can be shutting off your phone. Literally everything will wipe the entire cache on your iPhone because, Apple wants to make sure that as much room is available on iPhone for some reason. I have no idea. But that's what they decided to do. So there is a way that's my favorite way, and this is the Guardian's way. It's a great news site. They're another page just like Amazon that loads exponentially fast. They're absolutely amazing. So what they do is they do just like Amazon does, right? They initially load with no custom fonts. Next, they actually fetch the font just like Amazon, right? Nothing's changed so far, but they actually take the font, they change it into base 64, right? So they're requesting a base 64 version of the font, and they store it in local storage. And that might sound kind of funny, but most fonts are actually pretty small, and they can fit in, the 5-10 megabyte limit for local storage per domain. Next, what they do is on future page loads, it knows exactly if the font is there, right? If something gets wiped, it knows it's wiped, and it can just go through the process again. You're never going to get a flash up on style text this way. And what it does is, hey, if it's in local storage, I'm literally going to copy, paste it, and put it inside of the style tag immediately. And now the browser is going to see, hey, I can add that to the CSS I can add that to the fonts directory I have here, and all of a sudden your page loads immediately. It's really fast. And if you do want to see it live, I'm a huge fan of the Guardian this way, so I actually lifted it and I used it on our page. If you want to look at it, you can just go to our website and you can just kind of hit F12 and you can look in the resources tab in local storage and you can see that there's a big base 64 payload of the font. So far, I know there's a lot so far, so I'm going to do a TLDR of the network and the renderer here. All right. 1, network. Make sure you're using DNS prefetching, right? I think we've covered that about 3 times now. It's incredibly important. It's really easy to do. 2, make sure your servers are up to date. 3, use transfer encoding chunks. Stream your content. Do not make TCP wait. It wants to be your friend. Let it be your friend. Embrace it. Don't push it away. Now the renderer, here's the big points here that that Amazon knows that we don't. Is that CSS blocks rendering. So you want to inline as much critical CSS as you can. And then you want to use the CSS async patterns whenever possible. JavaScript also does wait for CSS to load if it's not async in the first. So make sure that you use these whenever possible as well. And please make sure to design for no web fonts. I know it's really, really fun to design your site with lots of web fonts, and you still can, but just make sure it still looks good without them, because the first time the user goes to your page, they may actually see it without it. Yeah.
Question about the Guardian implementation.
Yeah.
It seems that it would still suffer from the same issue of local storage being wiped on.
Oh, right. I actually forgot about that. Yeah.
Okay. Is that true when the base 64 just helped it because it inlines as opposed to saying go fetch a file?
So and thank you for bringing that up. I actually completely forgot about that. This is something that's really interesting. There were a couple guys that did research on how fast does cache get thrown out, what is the actual limit, because people say 5 megabytes, but can you store 50, right? And if you tweet at me at the OBTO, I can actually give you the research article if you're interested. It's really cool. But what they found out is that Apple, with how aggressive they are with cache, they don't touch local storage. They respect it. They don't touch it. They don't wipe it. It is there forever unless the user literally goes in and manually deletes it. It's fantastic, and that's why they use local storage. All right, so that is basically the vast majority of everything that Amazon does to make sure that they render their pages fast, speedily. They can select what parts of the page they want to load because they use async CSS. But there is one last part that Amazon does. And that's basically that now that we know all these things that Amazon does and how they do them, I kind of understand most of the shenanigans on their source code. But I still need to decide what to load and when to do it, right? That's a really big question. I mean, now that we have this power, what do we do with it? How do we use it for good, right? And so let's just kind of take a quick step back and what do we already know about users and load times and what do they find important? And we look at, I think most of us have probably heard of the, 0.1, 1, and 10-second rules, right? For something to feel instant, it has to load in 0.1 seconds. For someone to be able to feel satisfied with their web viewing experience, they don't start thinking about other stuff when they're loading the page. It has to load in 1 second. And then your page has to load within 10 seconds or else they close the page. The interesting thing about this is that all this data basically comes from a psychology article published by Robert B. Miller in 1968. Humans don't change, so this data is actually still very relevant. And what you find out is that he went through and he basically asked all these different questions that we as users asked the different machines, and he found out what are the different response times that we want for this. And as you read it, which is very interesting, you find out that all in all, what we really need to be doing in terms of, what content do we need to load, we need to think about the user's journey. And what do I mean by the journey? Well, let's imagine we want to bake chocolate chip cookies, because I'm actually a little hungry right now, so chocolate chip cookies sound amazing. So I'm going to Google chocolate chip cookies, and I'm going to load, whatever the first link is, whatever, right? I'm going to click on the button. Right? So first thing that's going through my mind right now, which is one of the questions that he actually covers in his article, is I am feeling incredibly anxious. I have no idea if I actually clicked the right link. Did I fat finger the link right above it or below it? Am I suffering by a phishing attack? I have absolutely no idea. Like, the browser's window is blank. Nothing is happening. I have no idea what's going on. And so the first and most important thing that Amazon does do, if you look back here, is within, let's see how fast they actually get this done, within 1 second, 0.7, they have given me enough information to tell me I am on the right page. This is not a phishing attack. I did not fat finger something. I am on the page to buy the Star Wars Force Awakens Blu-ray DVD. So, you want to first tell them, hey, I'm on the right page. This is incredibly important to do. Second, you want to think about what are my users really thinking? What do they really want to do? For Amazon, that's their buy button. And if you look here, the next paint, literally the next paint within 8 milliseconds is their buy button. It's a little bit different here. Because at the time we captured this, it was still like a little pre-order thing. But that's the very next thing that they render. So you want to kind of think, what is that initial goal they want to accomplish? So for me, wanting to make chocolate chip cookies, the first thing I want to see, I don't care about your header, your sidebar, your footer, maybe some of the related content I don't really care about. All I want is a picture of the cookies, because we all know that's how you decide chocolate chip cookies are good, right? They have to look good, right? That's really important. They got to be gooey. The chocolate seeds has to kind of melt. It's very important. And the next thing you really want is you want the recipe, because I want to see if I actually have all the ingredients. And you can usually find that out pretty fast if it says, hey, use raw sugar. I mean, I don't use raw sugar. I have like table sugar. So sometimes you might close it really fast. But and then after you've loaded that most important content, this is the time where you really need to sit down with your team and basically make a list of all the not every single element on your page. That would take way too long. You want to basically say, okay, we have basically the header here, we have the sidebar, we have the ads, we have, the video here, the related video, and we want to basically lay these out in order of what is the most important. And what's really cool is that you can still go back to Amazon, and they still do this, right? Hey, I want to add this to my list next. That's the most important thing. And where's the next render? Oh, now I want to enable people to go to their accounts. And, hey, now I want people to be able to see that this is actually good, right? They've got good reviews. And, I mean, you can keep going forward and forward and forward. And Amazon continues to paint things in order of the most important things that they have, obviously through tons and tons of user research, because Amazon loves data. What is most important? For more details on this, Sergey actually had a absolutely fantastic talk. I think it was back in November. That you should totally check out, because I don't think I have time here today to go through this more in depth. Totally check out his video. It's an hour long. It's absolutely fantastic. Highly recommend it. And then if you want to see anything from like my viewpoint here, this is the Web Perf, Web Perf blog. article that I wrote that Sergey mentioned that basically talks about this from a little bit of a different angle, but it'll give you that same viewpoint. So, that's all I have right here for today in terms of all the stuff that Amazon's doing that you may not be doing. But I just want to let you know that your journey here does not end. There's still a lot of different things that Amazon does do. I just don't have time to cover all of them here. So I picked what I found to be the most important, the easiest ones to implement that we can get massive wins on immediately. So here's three three links that will really keep you going because you don't want to stop. Right. First, I would highly recommend you check out Ilya Grigoryk's High Performance Browser Networking. It is a free book online. It's an HTML book. You can buy it too if you would like. O'Reilly has provided it online for free, so thank you, O'Reilly. But if you found the TCP stuff, the DNS stuff interesting at all, believe me, there are so many more speed-ups, interesting things. Like, for instance, the absolute mayhem that goes on when your phone actually tries to connect to the internet. There are massive speedups that can actually increase the speed of your site by like 20-30% sometimes as well. I just want to leave that as a little Easter egg to make you guys actually want to go and read it because it's a great book. Ilya's a really, really smart guy. Next, it doesn't have anything to do with coding, but I would highly recommend Dan Ariely's book called Predictably Irrational. Because a lot of times in web performance, now that we have these tools to actually decide when we want to render stuff and where we want to load it, it helps to be able to understand a little bit of psychology in terms of how do our users think? What are they actually wanting? Because a lot of times, as developers, we can kind of be a little bit distanced from that. But the thing is that we need to be at the forefront, understand this knowledge. And so this is a very high-level book. It's actually a lot of fun. It's a very fun read. Most people probably would not even call this a psychology book. But I would highly recommend it. And I know everyone says read the source, Luke, all the time, but really the HTML5 spec is incredibly well written. I don't know if you noticed, but some of the diagrams I use are actually ripped straight from the HTML5 spec. They did a fantastic job. I would highly recommend you check that out. So that's it for today, but I do want to, if anyone wants to get in touch, please do. You can email me at david@lookzook.com. You make sure to follow me on Twitter because that is where I will be sending out the slides for this tomorrow. And check me out on LinkedIn and, sign up for a beta, Why not? Does anyone have, yep.
Which would you recommend as the biggest wins of all the things that you discussed tonight? Is it on the networking side? Is it on the rendering side? Fonts?
Let me go back to the TLDR, because that, I think, let's go back here. There's a TLDR, couldn't see in the preview. The biggest, so that can be a little bit tough question to ask, because some of these can be ridiculously big wins, but a lot of work. And that's kind of something that Sergey, I think, even talked about in that talk I was talking about, is that there's a lot of performance gains, but as you go up in level, the amount of time, effort, and money you have to put into it kind of doubles each time. So I would say probably the fastest and biggest win is probably just inlining a little bit of critical CSS and using async CSS. It can be a huge win on so many pages. And the thing is that most of us right now are already bundling all of our CSS into one or two packages. So the order it comes in doesn't matter too much already. So you're already good to go. You can literally download this. I think it's 800 bytes is the load CSS thing on GitHub. And it can give you massive wins. That's probably the first thing that I would go to. It's really simple and fast to do. Yeah.
Are there tools that you know of that kind of enable it for you to kind of figure out what's the CSS that's necessary for what fold or whatever it is, the stuff that you want to inline? Because I feel like this is something that Amazon can do really, really well, but for a smaller team,
I understand.
Hard to scale.
So I have to look for it because I don't know exactly where it is. There is one in Chrome DevTools that I forget which tab it's in, but you can basically load the page and it will tell you all the CSS that is wasted. So sometimes a page might have 50% CSS that isn't actually loaded and used. And you can use that at least as a really good starting point to say, this is all the CSS that's actually on the page. So I guess a hack to using that tool would be something like make a minified, small little hack version of your page of the minimum stuff you want to load. load in all the CSS, use the Chrome Dev Tools to do that, and it'll tell you all the CSS you actually used. You can copy paste it.
Vertical CSS. You use it. It will generate it.
So if you just tweet at me, I can send you exactly where that is. I just don't know that off the top of my head.
Actually, I listened to Paul Irish on some podcast recently, and he's saying that this will be even having more improvement in Chrome DevTools. Like they will stream changes to that.
Oh, awesome!
Loads and interactions happening. So it hopefully will be more interactive. He didn't say when, but he's already saying that it will use a lot.
That's true.
There's a gem in the Ruby ecosystem that someone in our company used that fetched above the fold and cached above the fold inline CSS. I think it was called Critical CSS Library or something, and I believe that there's a node equivalent for that.
Oh, that's really cool.
One that's part of the filming groups with their async script. They've also got critical CSS.
Oh. Yeah, if it isn't clear enough, you should totally check out their GitHub repository. They've got a lot of gems there. All right, any other questions? Yeah.
Why do you think Amazon uses DNS prefetch instead of pre-connect?
That's a good question. So the thing is you can do a DNS prefetch can be. All right, so basically, I believe the answer is twofold, right? One is that pre-connect, I don't believe, is supported across all browsers, right? And Amazon is a very widely used web page, so they need to make sure it actually is usable in IE8 and stuff like that. And I believe DNS prefetch has been around one of the longest out of all of those kind of meta, help the browser figure out what's where stuff. So I think that's the first reason. The second reason is that pre-connect goes to the next stage. If any of you don't know what he's talking about, you know how I said that DNS prefetch basically goes and it sends off the DNS request to get the IP addresses so we can save that 100, 250 milliseconds of time, right? What pre-connect does is it not only does that, but it establishes the TCP connection already. So that can save you even more time. That's something that you'll actually find out if you read Ilya's book. But basically, the one downside to doing that is that you're going to have a lot of open sockets, and that could potentially slow down some other resources. I had to think about that more, what the downside to that would be. But that's actually a really interesting question. I think it probably just has to do with the fact that Amazon's optimizing for as many browsers as possible. Anyone else? Yeah.
I actually have a twist question. So, when you were asked which optimization to do first, which thing to do first, web technology, although in one of your further slides, you mentioned that people don't change. Well, would it be better to actually start designing sooner, so by the time they actually do that, you start that initiative early?
Oh, you mean doing which part starting early? Does everything early?
Your team to actually care.
Oh yeah, definitely. I was just pretty sure that he was talking more of an instance where they actually already have the page. But yeah, no, I think these are definitely that's why I wanted to talk about this here, right? If we can get this out to as many people as possible, and now one guy's turned into 50 and maybe hundreds more if we get that uploaded. But yeah, we want those initiatives gone early because all this stuff, as hard as and weird as it might sound, like actually streaming my data procedurally, because you'd have to design your backend completely differently in some cases, right? But if you're doing that from the get-go, it's actually not even that bad. You might make one extra database call just so that you can actually get some content out sooner. But I mean, in many cases, it can be easy. But changing an existing system can be very hard. Yeah. Anyone else? All right, good.